Did you know that a single gold bar sitting in Fort Knox is worth over $500,000? But here's what's even more shocking. That gleaming, perfect bar you see probably started its life in someone's old circuit board, a discarded smartphone, or buried deep in toxic mud thousands of feet underground. Every year, refineries around the world process over 3,000 tons of gold, worth approximately $180 billion. But the journey from raw material to those pristine 400-ounce bars is far more dangerous, complex, and fascinating than you could ever imagine. By the end of this video, you'll discover the secret chemical process that turns impure gold into 99.99% pure bullion. The shocking reason why gold refineries use more cyanide than you'd ever expect. And the one critical step that determines whether a gold bar is worth $500,000 or completely worthless. Let's dive into the billion-dollar world of gold refining. Before we can refine gold into those iconic bars, we need to understand where this precious metal actually comes from. And the sources might surprise you. The traditional source, of course, is mining. In massive operations across Nevada, Australia, and South Africa, companies extract gold-bearing ore from deep underground. But here's what most people don't realize. The ore extracted from these mines contains only about 5 to 10 grams of gold per ton of rock. That means workers are hauling literal tons of worthless material to get just a few grams of the precious metal. But mining isn't the only source. In fact, one of the fastest-growing sources of gold is right in your pocket. Your smartphone contains approximately 0.034 grams of gold in its circuitry. That doesn't sound like much until you realize that extracting gold from 1 ton of old phones yields more gold than processing 1 ton of ore from a mine. This is why electronic waste recycling has become a billion-dollar industry. Then there's jewelry recycling, dental gold from old crowns and fillings, and even gold recovered from industrial processes. All of these sources end up at refineries, often mixed together in various states of purity. Some incoming material might be 50% gold, some might be 90% gold, and some might be less than 10% gold mixed with silver, copper, and other metals. And this brings us to the first major challenge. How do you turn this chaotic mix of materials into pure gold bars worth hundreds of thousands of dollars each? The refining process begins the moment raw material arrives at the facility. Security is immediately visible because we're not dealing with ordinary industrial materials. We're handling one of the most valuable substances on Earth. First, everything must be carefully weighed and documented. Every single gram is tracked through a sophisticated computer system. If even a fraction of an ounce goes missing, alarms go off. The accounting here is more precise than most banks. For solid materials like jewelry, electronic components, or ore, the first step is smelting workers load the material into massive furnaces that reach temperatures of 1,950 degrees Fahrenheit, well above gold's melting point of 1,945 degrees. Added to the mix are fluxing agents, special chemicals that help separate gold from other materials. What emerges from these furnaces are called doré bars. Don't confuse these with the final product. Doré bars are rough, impure bars that typically contain 60 to 95% gold mixed with silver, copper, and trace amounts of other metals. They're valuable, yes, but they're nowhere near the purity required for investment-grade gold bars. For electronic waste, the process is even more complex. Circuit boards must first be incinerated to burn off plastics and other organic materials. The remaining ash and metal fragments are then processed chemically to concentrate the precious metals. This creates a gold-rich sludge that will eventually join the refining process. But here's where things get really interesting. The methods refiners use to achieve 99.99% purity involve some of the most dangerous and precise chemical processes in any industry. And there are two primary methods used worldwide. The first method, and the one that produces the absolute highest purity, is called the Wohlwill process. This is an electrochemical refining method that can achieve 99.99% purity, sometimes even 99.999%. Here's how it works. The impure gold doré bars are cast into anodes, which are thick plates suspended in a specialized electrolyte solution. This solution contains gold chloride and hydrochloric acid. On the opposite side are pure gold cathodes, thin starter sheets of already refined gold. When electrical current passes through this system, something remarkable happens. Gold atoms from the impure anode dissolve into the solution, travel through the liquid as ions, and deposit onto the pure gold cathode. Meanwhile, impurities like silver and copper don't dissolve properly and fall to the bottom of the tank as a muddy sludge. Even other precious metals like platinum and palladium can be recovered from this sludge later. Over the course of several days, pure gold builds up on the cathodes while the anodes slowly disappear. The pure gold is then melted down and cast into bars. This process is incredibly precise, but also relatively slow and expensive. That's why many refineries use it only for gold that needs to meet the highest purity standards. The second major method is the Miller process, which uses chlorine gas. The impure gold is melted in a crucible, and then chlorine gas is bubbled through the molten metal. The chlorine reacts with impurities like silver and base metals, forming chlorides that float to the surface as slag. This slag is skimmed off, leaving purer gold behind. The Miller process is much faster than the Wohlwill process and can refine gold to about 99.5% purity in just a few hours. However, it can't achieve the same extreme purity levels. That's why many refineries use a two-step approach. First, the Miller process for rapid purification, then the Wohlwill process for final refining. But regardless of which method is used, there's one substance that virtually every gold refinery uses in massive quantities, and it's one of the deadliest chemicals known to humanity. If you've been paying attention to gold mining news, you've probably heard about cyanide. Many large-scale mining operations use sodium cyanide to extract gold from ore through a process called heap leaching. The cyanide binds with gold particles, allowing them to be separated from worthless rock. But here's what fewer people know. Some refineries also use cyanide-based processes, particularly when dealing with low-grade materials or complex ore concentrates. The process creates a gold cyanide solution from which pure gold can be precipitated out using zinc or activated carbon. The use of cyanide is controversial and dangerous. A single teaspoon of a 2% solution can be fatal to humans. Refineries that use cyanide must follow extreme safety protocols, sealed processing systems, continuous air monitoring, emergency showers and eye-wash stations every few feet, and specialized ventilation that processes thousands of cubic feet of air per minute. Environmental regulations surrounding cyanide use are strict. Wastewater must be treated extensively before disposal, and any solid waste containing cyanide residue must be handled as hazardous material. However, it's worth noting that many modern refineries, especially those processing high-grade materials, have moved away from cyanide-based methods entirely, relying instead on the electrochemical and chlorine-based processes we discussed earlier. Now, once we have pure gold through any of these methods, you might think we're done. But we're not even close. Turning pure gold into those iconic gleaming bars requires several more critical steps. Pure gold fresh from the refining process is typically in the form of small grains, beads, or thin sheets from electrolysis. To create standardized gold bars, this material must be melted and cast. The most common investment-grade gold bar weighs 400 troy ounces, or about 12.4 kilograms. At current gold prices, each of these bars is worth over $500,000. Creating one requires incredible precision. First, the pure gold is loaded into a crucible inside an induction furnace. These furnaces use electromagnetic fields to heat the gold without any direct contact, preventing contamination. The temperature is carefully controlled to reach about 2,000 degrees Fahrenheit, just above gold's melting point. Once molten, the gold is poured into preheated bar molds. These molds are typically made of cast iron or graphite and are heated to several hundred degrees before pouring. Why? Because if you pour 2,000-degree molten gold into a cold mold, the rapid temperature change can cause the gold to crack or create internal stresses that weaken the bar. As the gold cools, it contracts slightly. Skilled casters know exactly how much gold to pour to account for this shrinkage and end up with a bar of precisely the correct weight. We're talking about precision down to a fraction of a gram on a 12-kilogram bar. But here's where things get critical. Even the slightest impurity at this stage can ruin everything. A speck of dust, a trace of the wrong metal, even oils from someone's skin can contaminate the gold and reduce its purity below acceptable standards. That's why casting rooms are maintained as clean room environments with filtered air, and workers wear full protective equipment. Once cooled, the bars aren't quite finished. They need to go through several quality control steps that determine whether they're worth hundreds of thousands of dollars or must be melted down and recast. This is the moment of truth. A freshly cast gold bar might look perfect, but looks can be deceiving. Before it can be sold or stored in a vault, it must pass rigorous testing. First comes weight verification. The bar is placed on an extremely precise scale that measures to within 0.01 grams. Remember, we're dealing with a 12.4 kilogram bar worth over $500,000. Even a 1-gram discrepancy represents thousands of dollars. Next is purity testing. The most common method is X-ray fluorescence spectroscopy. A specialized machine fires X-rays at the bar and analyzes the energy signature of the atoms bouncing back. Different elements emit different energy signatures, allowing the machine to determine the exact composition of the gold. For a bar to qualify as good delivery gold, the standard accepted by major markets worldwide, it must be at least 99.5% pure. Some refineries also use fire assay testing, a centuries-old but incredibly accurate method. A tiny sample is scraped from the bar, wrapped in lead foil, and heated to extreme temperatures. The process separates gold from all impurities, and the resulting bead of pure gold is weighed. By comparing this to the original sample weight, technicians can calculate purity to within 0.01%. If the bar passes all tests, it receives a stamp. This stamp includes the refiner's mark, the purity level, the weight, and a unique serial number. This number connects the bar to complete documentation about its origin, refining date, and test results. It's essentially a birth certificate for gold bars. Bars that meet the good delivery standard can be traded on international markets, stored in central bank vaults, or sold to investors. Those that don't meet the standard must be melted down and reprocessed. There's no such thing as close enough when you're dealing with hundreds of thousands of dollars per bar. So there you have it, the complete journey of gold from raw, impure material to gleaming bars worth hundreds of thousands of dollars each. We've seen how refineries process everything from mining ore to old smartphones using dangerous chemicals and precise electrochemical processes to achieve 99.99% purity. We've witnessed how molten gold is carefully cast into standardized bars, tested with incredible precision, and stamped with certifications that allow them to be traded on international markets. And we've followed these bars as they enter some of the most secure supply chains on Earth, ending up in central bank vaults, investment portfolios, and even back in the electronics that might one day be recycled into gold all over again. Did anything in this process surprise you? Let me know in the comments below. And if you enjoyed this deep dive into industrial processes, make sure to subscribe because we've got plenty more factory tours and manufacturing breakdowns coming your way. Thanks for watching, and I'll see you in the next video.